In this video, I am going to explain about the operation of heat exchanger system which we are using in one of our teaching facilities. If we look at the figure, the heat exchanger is labeled as HE101. The hot fluid from the preheat water tank is transferred to the heat exchanger by a pump which is labeled as P101. The hot fluid flow from shell side inlet and then pass through the shell side outlet. For the tube side of the heat exchanger, colder fluid is pumped using P102 to tube side inlet and then passing through the tube side outlet and flowing towards the upstream processes. For simplicity, heat transfer happen in heat exchanger will turn the colder fluid into hotter fluid on the tube side outlet, and on the other hand, hot fluid will become cooler on the shell side outlet. In terms of temperature monitoring, the temperature monitoring for tube side inlet is done using temperature transmitter TT103. For the tube side outlet, the temperature monitoring is done using temperature transmitter TT104. For shell side outlet, the temperature monitoring is done using temperature transmitter TT102, and TT105 is used for temperature monitoring for the shell side outlet. For TT102 is for shell side inlet and TT105 is for shell side outlet. But in industry, actually, instead of using a hot water, in industry, steam or even superheated steam is used instead of hot water. The steam, of course, is generated by boiler system. Meanwhile, for the tube side liquid, it could be hydrocarbon, it could be vegetable oil, it could be a mixture of chemical liquid, for example, or even could be a gas. Okay. Now I'm going to explain how can we conduct an open loop test for this particular training unit. First, we have to ensure that the pump P101 is turned off, no hot water flowing into the shell side of the heat exchanger. And then the observation of the temperature, we have to observe the temperature of the preheat water tank via temperature transmitter TT101. This is to ensure that the water temperature is high enough. Meanwhile, we have to turn on the pump P102 to allow colder fluid to continuously flow through the tube side of the heat exchanger. Also, we have to observe the temperature transmitter TT104 to ensure that the water temperature is about room temperature. So it's around 24, 25 or around 30 degrees Celsius depending on the room temperature at that time or surrounding temperature. And at this time, the reading of TT103 and TT104 could be almost identical, okay, because there is no heat transfer process happen in the heat exchanger. In terms of the actuator, the regulated control valve, so the regulated control valve CV101 and CV102 is allowed to open at 100% opening. This is to allow a maximum flow rate measured at FT101 and FT102. The experiment will be done in 1800 seconds. This is to allow the heat exchanger to achieve a steady state. An open loop experiment is actually conducted or will be conducted using the integration of MATLAB and Simulink software. We also use another software for the OPC, what we call as the Capware EX OPC, and also we are using the TIA Portal software because we are also using the PLC. Once all the setup is ready, turn on the pump P101 to allow the hot liquid to flow into the shell side of the heat exchanger. We can see from the plot that the open loop test provide useful information about the process dynamic of the temperature system. And then we're going to use this particular data for system identification exercise later on. And all this data, all this useful data, all this informative data is recorded and logged using MATLAB software. Okay, that's all for this time. Thank you for watching.